Differential Calculus 2014, question 10b. A particle moves in a straight line with acceleration of 2t minus 3 ms to the minus 2 at a time t seconds. At time t equal to 0, the particle has velocity of 2 meters per second and displacement of 1 meter relative to a fixed point O on the line. Find, firstly, in terms of t, find the times when the particle changes direction. Well, if it changes direction, going this way, it has to stop temporarily before going back this way. So v is equal to 0 when it changes direction. So we need to get an expression for v. We know that v is equal to u plus at, and we have acceleration up above. So dv dt, if we differentiate this expression, we'll get our acceleration. So we can say that dv dt is my acceleration, which is 2t minus 3. So if we want to get an expression for v, we need to get v on its own. So we're going to need to integrate dv, 2t minus 3 dt. So if we integrate these, what information are we given? At time t equal to 0, so it's going to be between t and 0. The particle has a velocity of 2, so the 2 is when t is 0. So if we integrate these, we're going to get v between v and 2 is equal to 2t squared over 2, so just t squared minus 3t between t and 0. So we're going to get v minus 2 is equal to t squared minus 3t. So my velocity, an expression for it, is t squared minus 3t plus 2. And that will have to be equal to 0. So the times, this factorizes nicely. So t times t minus 2 minus 1, it's going to give me minus 3t. So when t is equal to 2 and t is equal to 1, it changes direction because they're the solutions for v is equal to 0. Part 2, an expression for the displacement. So we want s of the particle from O at time t. Okay, let's see what we have here. We want s is equal to ut plus a half at squared. So ds dt is equal to u plus 2 times a half, which is 1 at, which is equal to velocity. And we have velocity up here. So this will enable us to get back to s. So we can say ds dt is equal to t squared minus 3t plus 2. So ds is equal to t squared minus 3t plus 2 dt. So we integrate these. If we integrate ds between, and we're given, what information are we given here? We're given this displacement 1 meter at a time t. So between s and 1, and between t and 0 will give me, initially it's 1. So this will enable me to get an expression for s. So s between s and 1 is equal to t cubed over 3 minus 3t squared over 2 plus 2t between t and 0. So we're going to get s minus 1 is equal to, we just have a t, the 0 will just go to 0. So t cubed minus 3t squared over 2 plus 2t. And we have to bring the 1 across to get our expression for s. T cubed over 3 minus 3t squared over 2 plus 2t plus 1 is my expression for s. Then in part 3, we're looking for the total distance traveled in the first 2 seconds. Total distance traveled in the first 2 seconds. Let's look at that. So because this changes direction, we're going to need to look at t is equal to 1 the first second, firstly. So we have, when t is equal to 1, s is equal to 1 over 3 minus 3 over 2 plus 2 plus 1. 3 minus 1.5 plus a third. is going to be 1.5 plus a third, 3 over 2 plus 1 over 3, which is equal to 9 over 6 plus 2 over 6, so 11 over 6. Now it started at 1, so we imagine here there was a 1 meter, so we need to take away 1, and it will have travelled 6 meters because it's at 11 over 6 at that point. So we do the between 2 and 1, so t cubed over 3 minus 3t squared over 2 plus 2t plus 1. If we imagine this interval on its own, we've already got t is equal to 1, so this is going to be 11 over 6, this one here. So if we put 2 in, we're going to get 2 cubed, 8 over 3, so this is t is equal to 2, 8 over 3 minus 3 fourths, 12 over 2, plus 2 2's are 4 plus 1, so this is 6 plus 5 is 1, sorry, 5 minus 6 minus 1, so 8 over 3 minus 3 over 3 is equal to 5 over 3. And then we would need to take away the 11 over 6, so this is 10 over 6. Well, I'll do the 11 over 6 in front, it will be absolute value, so that's going to be 1 over 6 meters in that second interval. So these two added together is going to give me 1 meter.